terms of preparation for the prelims and the way forward in terms of examination. Colleagues, for me to make sure that all the provinces are present, we should to make a roll call so that we know who's in the house, who is not in the house. Remember, this is an official meeting. It's for DBE, and I report to DBE, and whatever eventuality or events that took place, I must report. So this it's an official meeting, and you may sometimes we may have a director, Mem Kembo, joining us because we send a link to her to join. If we happen that she joined us, we'll allow her a few minutes to say one or two words. But colleagues, let me start by checking that Eastern Cape, it's here.
Present.
Can you please, if you say you are here, state who's your name and where you're from, so that it's recorded. Thank you. Eastern Cape.
I'm Miss Makongana from General Makutiana or Tambo Inland.
Thank you, Ms. Makongana. Thank you. You are welcome, Eastern Cape, all of you, and under the banner of Mr. Mlwema, Richard. I believe he will be joining us if he has an opportunity to join us. But welcome, Eastern Cape. Can I go to Gauteng? Can you Gauteng?
Yes,
I am
Gauteng is here.
Yes.
Yeah, who's here?
Right. I'm from Mamelong Comprehensive in Gauteng East.
Mamelong. Who's the name?
Yes. Makamut Gloria.
Makamu Glory from Mamelong. Thank you so much,
Yes.
Ma'am Gloria. Makamu, thank you so much. You are welcome. And I want to welcome all the Gautengeling in the house. Thank you so much. Then I therefore go to Free State. I didn't want to call Free State because it's the one present, but let me just check. Free State is in the house. Free State.
Mr. Mwikiti, Magabelani Technical High School in the Free State, present.
Thank you, sir. Thank you, sir. You are welcome, Free State. I didn't want Mr. Nambane to say anything because he's the one who's presenting from his state, but I just want to welcome all the team from Free State. You are welcome. And can I go to KZN?
Good afternoon, colleagues. KZN is in the house. This is Mpolisi Derek Sitole from Herikwala District. Thank you.
Thank you, Jobe. Thank you so much, Jobe. You are welcome with all your team. We appreciate your presence. Thank you so much. KZN, you are welcome in this meeting. It is your meeting as well. Can I go to Mpumalanga? Mpumalanga? Mr. Tladi or Mem Konza? Anyone from Mpumalanga? No. Then let us go to Limpopo.
Good afternoon, colleagues. Good afternoon, Bujabu.
Hi,
Tlala
Memta.
KM is available from Limpopo, Skukun South District. Yeah, I'm here with my colleagues. Some of my colleagues are already in the platform. Thank you very much.
Thank you, Memta. Thank you so much. We appreciate your presence and with your team. And I believe that your boss will be in the house as well, if I believe so. Mr. Peter Mukweba, is it going to be? If he's in the house, we welcome him.
Yeah, I think he will be joining.
Okay,
He will join. Thank you.
Thank you so much, Memtala. Can we go to Northern Cape? Northern Cape.
Honorable greetings, everyone. Salima Mudama here from Daniel Scale Combined High School. Some of my colleagues did make excuses. They did say that they're vigilating at their schools. That's why they didn't attend.
Okay, Mudama. Thank you so much, but we appreciate that we appreciate your presence, and we believe that Mr. Lepate will join as well in time. But we welcome you. Welcome all the Northern Cape colleagues. You are welcome. Northwest.
Colleagues, good morning, good afternoon. Leadership, how are you?
Good leader. And how are you?
No, good. Colleagues, Mr. Shongwe here from Northwest, the provincial coordinator for technical science. Leader, yeah, I'm with, well, how can I say, 15% of my teachers are here, but hopefully in due course, some will join, almost all of them. So, yeah, we had some couple of commitment on our side, but I'm happy those were committed. I can see there, because they were finalizing the internal setting of the grade 10 and 11 question papers. But I'm happy that now still I can see them here. It means they are done. Other than that, leader, we're looking forward to this fruitful activity today. Thank you.
Thank you so much, Mr. Shongwe. Thank you. You are welcome with your team. I wanted to say, I want to hear one of your team saying, welcoming us before we called you, because we want to hear their voices. But the boss
No, it's fine.
The boss has spoken.
Mutongo.
No, the boss has spoken. The boss has spoken. It's okay. The boss has spoken. They will interact with. They will interact with. Thank you, guys. Thank you. You are welcome, all of you there with your boss. You are welcome. Thank you so much. Can we go to Western Cape?
Good afternoon. Can you hear me?
Yes.
Good afternoon. Fabian Valentine here, Western Cape Provincial Coordinator. I'm here. I do see a couple of names I recognize in the meeting, but many of them will be joining a little bit later as most schools end at 3, and it's not always possible for teachers to get a little bit of leeway. But we are here, and more of us will be in the meeting in due time.
Thank you, Fabian. Thank you. Thank you, Fabian. Thank you so much. You are welcome with your team. We appreciate your presence in this meeting. We only have one province that it's not in the meeting, which is Mpumalanga. Mpumalanga, we go back to you. Are you there? Is that Mpumalanga? No.
Sorry?
Yes.
Yeah, can we go back to Gauteng?
Gauteng?
Yes, it's Mr. Winston Vandama from Voortrekker School, Technical Science, yes.
Okay, thank you.
Yeah, I'm also here.
All right, thank you, Mr. Pandama. Thank you so much. It means Gauteng is represented twice. It's okay. We appreciate that. No, we appreciate that. We appreciate. Thank you, Mr.
Yeah, thanks.
Pandama. Thank you for the presence and standing in for Gauteng as well. Thank you. You are welcome. Colleagues, without any waste of time, can I make this plea to you, colleagues? As you enter into this meeting, can we have the protocol of the meetings? Number one, make sure that your mic is muted. Make sure. Take out the, check your mic that is muted right now. Then you take out the finger there out of the mic so that it cannot be disturbed. If you are kicked out and you come in, just check the mic that it's muted, colleagues. Let us please check the mic often that is muted. Two, you will be given a chance maybe after the presenter has presented or in the middle, anywhere where you want interaction. Let us raise our hands. Then you'll be afforded an opportunity to speak. After you shall spoken, please lower your hand because it will be disturbing to see the hand hanging there. So please, colleagues, and even your camera, make sure that you close it. We'll appreciate to see you. We want to see you, but you are many in this platform. We are 60 of you. If we can say open the camera, it can be a havoc. But colleagues, let us make sure that our cameras are closed and then our mic are muted. Then you will be afforded an opportunity, definitely, to interact, colleagues. This is our as I said it to you, it's our own meetings. Now, with me, I have Mr. Nambane. He's the technical subject coordinator at Free State. He's the one who's going to take us through the paper 2 in preparation for our learners. Colleagues, from here we go back to our learners, we prepare them as to how are they going to answer the questions or how are they going to attack the question paper to get the results. Remember, the mandate still stands to all of us on call, that the mandate is 100% from the school, district, head office up to the level of the national. It's 100%. We cannot falter. We have faltered yesterday and last year we've dropped the results. This year, foot on the pedal. Every one of us, foot on the pedal. We are accelerating to get the 100%. So if we don't get the 100%, there will be accountability of some sort. There should be accountability across the board to say how we didn't get that 100%. So I'm just bringing this to you, colleagues, that the mandate still stands. It's 100%. All the provinces, the 9 provinces. So it means the schools, the district, the head office must give 100% to national. That is the mandate. So colleagues, let me take this opportunity to hand over to Mr. Nambane to take us through his presentation, the lessons. Mr. Nambane, the platform is yours. Thank you, sir.
Thank you.
Before Mr. Nambane, timelessly, colleagues will be telling you to fill in the register. Please, if the register is on the chat box, don't write on the chat box, click to the register, then the link there, and you fill in. For now, it's not there. We are still preparing the register. Then you will fill in the register. Please, colleagues, please. Thank you, Mr. Nambane. I'm sorry for that. You can take over. Thanks.
Thank you very much, Tate Stole. Colleagues, good day. And special thank you to Tate Stole for organizing such a big event for technical sciences, paper 2 revision tips. It's such efforts that will take us to the desired and promised land of 100%, and is the means of technology and visual platforms, ICT integration, that can also make it easy for us to reach a wider audience across the entire South Africa. To all the PSCs, Provincial Subject Coordinators of Technical Sciences, thank you very much, colleagues, for distributing the links to our teachers such that we can be in one platform and discuss issues of technical sciences. And a special thank you to the teachers also for the sacrifice of being here. It's a crunch time in all the provinces. The trial examinations have started. It's last push and first push. All these nice ways of explaining how much we support our learners. Colleagues, when one was sitting down trying to compile this presentation, it was a little bit challenging because one was sitting and thinking, do we take the approach of us attending to the misconceptions? Do we take an approach of closing the gaps identified? Or do we actually consider the fact that this platform is for the teachers and we need to pitch at a certain level? So colleagues, it is a mixture of all, but I believe the takeaways after this should be inputs and efforts that are going to take our learners forward. Ladies and gentlemen, I am Tate Nambane, as it was said, so I'll be going through everything that we compiled as the Free State, and we hope that all other provinces can give us their inputs so that we can also improve as a province, such that we can improve as a subject, but we tried to have different ways of approaching this particular session. So it's a mixture of everything that we thought it's important for this, but we also consider the issue of we don't want to prolong it such that at the end we lose now the key motive of this. Colleagues, the preference of the presenter is that kindly allow the presenter to finish everything such that the presenter can have a nice rhythm because the slides are arranged in a particular way. Once the presenter is done with the presentation, after noting all your questions, then we will open up, we will go back to the slides, we will engage so that we can maybe ensure that we have a clear understanding as we move forward, so that the rhythm and the understanding of the PowerPoint itself and the interaction with the content does not get distorted anyway. Ladies and gentlemen, key notes that we need to take note of. One, ladies and gentlemen, is as we prepare, it is important that we understand that curriculum and assessment policy statement, which is the CAPS, specifically looking for technical sciences, is the one that governs the entire body or the entire concepts that needs to be treated in the technical sciences. If we do not do so, already we are creating a gap because now whatever assessment is going to be there, we are going to have key challenges to say, but this key bullet we did not attend to. So it is important as colleagues to say, when we go back and trying to reflect on the results of term 1 and term 2 and the concepts of the entire technical sciences, are we sure that each and every bullet in the CAPS document is now attended to? But I want to take your attention to this one, colleagues. Why specifically this one of the Technical Sciences Grade 12 Examination Guideline of 2021? Is because it is giving specific details regarding the themes to be tested in each of the knowledge areas. Last year we got a surprising question in one of the examinations that were written in 2020, 2025 and 2024. And for one simple reason, it's one bullet that as colleagues we tend to not teach, or to tend not to say, let's put emphasis on this particular concept where it says application in terms of technology or any industry that relates to the technical sciences. So it is important, colleagues, to say when we revise, when we plan accordingly, can we tick and check that in the examination guideline, all the key bullets that are going to be tested have actually been assessed in a daily activity, in an informal test, in a revision activity. It is important to do so, such that we give now our learners a fair chance to actually compete with now what? With the exam that is coming. Already, if they go with gaps, that says now every bullet in the examination guideline is not attended to, then we are failing the learners, then we have not prepared them the best way we can. So colleagues, so it's key to say even the activities that we are going to give as part of the revision, the question papers that we are going to do, are they actually addressing the key concepts of the particular subject that we are referring to now? Colleagues, it outlines the format of the question paper for both the chemistry part and the physics part. Knowledge that is required from grade 10 and 11, and the core content that will be assessed in the final examination. Colleagues, last year, I will forever refer to the new trends of the question papers for a simple reason. Content of grade 10 and 11 that is relevant to be assessed in grade 12. It is important that we also try to integrate the concepts of grade 10, concepts of grade 11 by ensuring that whatever that is going to be assessed, it is now entirely covered across the entire grades. They will not only assess the content of grade 12 in simple terms. If there's integration of redox reaction from grade 11, then it will be easy to say we need a certain prior knowledge that these learners should have from grade 11. So we will need now, colleagues, to be aware in terms of topics integration or concept integration within the paper that is now coming. We all do it, colleagues, in all our provinces, especially those that are involved with the marking and the setting of internal papers. Colleagues, we are always referring to the diagnostic reports for the purpose of ensuring that we ask the common errors that our learners are doing. From that, we also try to ensure that we mitigate the common errors by repeatedly assessing the common errors that were identified. So as you sit down preparing for the final push or the first push for the trial examination, colleagues, it is important that each and every one of us, we acclimatize ourselves with the diagnostic reports, especially the performance also of paper 2 between 2021 and 2025. So as I was preparing this also, I took few hinters there to say, but if this is a key problem of the entire country, how best can we enhance the teaching? How best can we ensure that we assist the learners such that they are at least 99.9% ready for the exam that is coming? And it's clear, colleagues, hence it says the National Diagnostic Reports give specific details on common errors and misconceptions that were identified in the previous examinations, providing crucial a practice in subject areas and questions that have caused problems for the students in their past. The cohort that we have now, it's not the cohort that wrote the paper of 2021 to 2025. However, their learnings and their errors that they have committed, they can assist in terms of providing suggestions for improvement in relation to teaching and learning. So please, colleagues, let's take note of this. Our teaching and our support should be a focused support. Focused support is to say we cannot start everything from the beginning and saying I am going to teach from bullet number 1 to bullet number 22 of the ATP. We are not saying all other bullets are not important, but now have a sort analysis of your client to say, but my problem with the learners is 1, 2, 3, 4, 5. It's not the entire paper. Once we hammer on those ones, we will be able to say we have provided suggestions for improving in terms of teaching and the learning. What is important is the teaching, colleagues. We are all doing our best as said, but the learning concept, the part where the learners must reciprocate, where the learners now must multiply in terms of the output, is where we have the key challenges in paper 2. But if we teach to address the misconceptions and common errors, we will be in a position of ensuring that we actually assist the learners the best way we can. Colleagues, notes still to the teachers, and this is an examination guideline extract. It says here, the prior knowledge from grade 10 and 11. All skills of knowledge learned in grade 10 and 11 are applicable for assessment. There it is, colleagues. They are applicable for assessment. So even when we revise and we teach, it's important for us to say what skill is needed from grade 10. What content knowledge is needed from grade 10 that is now applicable in grade 12. And because of there's been ways, colleagues, to say our curriculum of technical science is disjointed, the examiners are coming up with ways and strategies to actually do what now? To cooperate and include the concepts of grade 10 such that we can have a nice build up into the concepts of grade 12. In addition to the content from grade 10 and 11, included under the examinable content for grade 12, skills and knowledge from grade 10 that may be assessed in grade 12 include the following: use of calculations or equations. We can also, colleagues, include here conversions if that is now important for paper 2, but is one of the skills that I am suggesting and thinking that in the near future as one of the things that will be coming into the paper of paper 2. Content knowledge acquired in grade 10 and 11 and the context applicable to technology. Colleagues, this bullet is very important. Let's note it down. The CAPS document, the foreword, says technical science is a subject that is introduced to the learners for them to have industrial skills in engineering, mining, and any chemical industry. The trend that is coming is to say, how do we now include industrial application? The context applicable to technology. Those bullets at the bottom of the annual teaching plan that we feel that, but for technical science, not so much important, colleagues, they are needed. The trend is there. And the fact that we want to differentiate technical sciences from the physical sciences, our assessment should be more practical, our assessment should be more applicable, should be more of industrial application. And it is there, and it is saying it as the examination guideline. It is saying the context applicable to technology. So when we revise, colleagues, please let's ensure that we work onto that, because all of us are in a position of saying, but now how does the subject link with the industry? That is now what we need to be making sure that we emphasize as we move forward. It says, note, colleagues, although there might be no direct questions about these aspects, applications thereof may be assessed. Very important, ladies and gentlemen. As we move forward, discussion of the framework for technical sciences exam paper 2, and this is just an example. Colleagues, the trend is very simple. It's just to say examinable aspects, we must refer to the examination guideline of 2021. Do we have demanding questions as we talk to our learners? As we have our science talk, it's important to say, let's our learners understand the chemistry vocabulary and the terminology per topic. Chemistry vocabulary will assist them to interpret any STEM given in the question paper. Chemistry vocabulary will unpack keywords that are needed in actual giving of the definition or the concept itself, or in actual fact, what is it that the question is asking. Bullet number 2, conceptual understanding. Do we teach for learners to understand, or do we teach for learners to answer questions? A very difficult question for all of us to answer. Because when we open the book of the learners, they have pasted the question paper of 2021, 22, 23, 24, 25. But do they actually understand the concepts? Did we actually bring about conceptual understanding? Because it's clear the question paper of last year will not be the same as the question paper of 2026. But do they understand the concepts such that they can compete fairly with the paper? And how do we enhance conceptual understanding? Do we take the question paper and say, you answer question 1.1, 1.2, 1.3, and 1.4? Does that assist them in understanding the concept? Does that enhance the level of understanding and the vocabulary of the chemistry and the terminology thereof? Once conceptual understanding plays a role in understanding or demanding questions, it will be easy for procedures to calculation, any calculation. But for this particular subject, we only have one calculation of electrochemical cell, especially in a galvanic cell. But the procedure to calculation will be easy, because you cannot calculate if you have not identified or understood what is oxidation and what is reduction. Because it's important for one to actually understand the concepts before they can actually do any specific given calculation. Ladies and gentlemen, bullet number 4 is even highlighted in blue. It says descriptions, explanations, writing balanced equations, and interpretation of graphs and flow diagrams of the chemical reactions in organic molecules. Colleagues, question 2.4. Write down a balanced chemical equation or reaction for the above reaction, or give a complete oxidation of what. Once the graph is introduced, does it mean there's no bullet in the subject that says no graph interpretation? But if the graph links now to the concept, is it wrong? The flow diagrams for them to ask in the organic reactions, if now they decide to take the flow diagram and combine it with the organic molecules or nomenclature in question 2, will that be wrong? No, colleagues, it is not wrong, because the conceptual understanding will have taught us to link everything that has to do with organic chemistry together. The conceptual understanding will have assisted us to actually now be in a position of integrating the knowledge of a galvanic cell to the knowledge of the electrolytic cell. By creating what? By creating procedures to actually understand the concepts. And what is our strength, colleagues? Our strength is the documents that we have. Our strength is we taught the learners, and we now need to be sure that we teach all the concepts per content aspects. That has been addressed as per the CAPS and the examination guideline, such that when we compete wherever platforms that Ntatestol is going to create for us, we will be able to say, but examiners, we do not see any bullet that refers to this. But if it is within the scope, our learners, because of the conceptual understanding and the chemistry vocabulary and the interpretation of graphs and flow diagrams, they will be able to say we are able to compete with this particular paper. All aspects, scenarios, and processes addressed in line with 2021 examination trends and national diagnostic reports. All aspects and scenarios. So those people that have a good eye of spotting, colleagues, they will say, no, in 2021 they asked this, in 2022 it was asked like this, 2023 it was like this, and 2024 and 2025. Colleagues, we do not know the exam. And it will not be an exam if it looks similar to the one of 2021 and 2022. So our strength is to ensure that all aspects and scenarios or processes are addressed in our daily teaching. In our revision, as we now talk of how best are we going to prepare our learners for examination. What is important here is the examination prep and examination readiness for our learners. All concepts per content aspects must be addressed as per CAPS and examination guideline. At this point, our learners have written much control test, which did not have part of the chemistry. And then they had the June examination, mid-year exam. Colleagues, we should have done an error analysis here. We should have done an error analysis. Why error analysis? This is for us to reflect with the learners, particularly on the gaps that might have been identified during the mid-year examination. The preparatory exam is in green, colleagues, because it's only coming. But immediately after the prep exam, we will now be able to say in mid-year exam and preparatory exam, these are now the challenges. So it basically says by the time we get to the final examination in October, end October and early November, then we are in a position of saying, but all the challenges that my learners were experiencing from the entire year or during mid-year and the preparatory exams, I'm in a position of ensuring that we are able to do so. And it says, where necessary, talk to individual learners, both high achievers and those that are struggling. Make the revision or the final push sessions to be about closing the gaps. You cannot close the gaps if, colleagues, you did not reflect with the learners. And it's important for us to say, even if we want the 100%, we must support each and every child, both high achievers and those that are struggling. Colleagues, the weighting of the prescribed content, math and material, 47 marks, and chemical change, 28 marks. The exam is 75 marks and 1.5 hour or hours. And you can see, colleagues, level 4 is only 5 marks. This is now level 4 type of question, and this is just the calculation there. If it is not a calculation, then it will be now that application that we referred to, the application that we referred to. So this might be 3 and this might be 2, but if we intend on saying the entire 5 or 5% thereof, yes, so 5%, then it will basically say we are looking at such a distribution of marks there. So it's important for us to exactly explain, to say where and how will they be able to get the marks. Colleagues, this is where now the challenge is. Matter and materials 47 marks, chemical change 28. What is the breakdown per topic? These learners, nomenclature, they are so fine, okay. Physical properties, they are so fine. But now in organic reactions, that's where the challenge is. So it's important for us to say, let's check the trend and say which aspect or what is the actual breakdown per topic. And colleagues, these are the estimates that when we sit down and analyze the papers, you see the trend to say, oh, more or less, this one is plus minus. So it is the trend and the averages from the 2021 to 2025 to say it is important to note that electronic properties of matter, because we fought for it to say, but it is there and you assess it for 2 marks, 3 marks. In actual fact, what are you saying? Are you saying we should not be teaching electronic properties of matter? And then the agreement was set to say, no, every aspect in the ATP on the CAPS document and the examination guideline will be assessed. And now the new trend that is coming, colleagues, is to say, yes, we are including electronic properties of matter. And hence the PET of 2026 is also referring to electronic properties of matter. So when you plan your preparation, colleagues, please ensure that you can maximize exposure in terms of electronic properties of matter. Those graphs of reverse and forward bias as the possible graphs that can form part of the electronic properties of matter. Anything, and that is the concept where learners now are not doing so well. Why? Because we tend to have that thing of, but the trend says this thing is only 2 marks and we do not teach, or we do not emphasize the importance of it. Like I said, colleagues, this is me saying the trend and allocation of marks, more or less plus minus, we are looking at this for us to actually make the 75. So colleagues, organic chemistry nomenclature 14 marks, organic chemistry physical properties around 9, it's a plus or minus, remember colleagues. Organic reactions 13 marks, and the question will be, why so many marks there? Colleagues, is clear. We have a lot of challenges here. We have a lot of challenges. And how do you address challenges? You continue by assessing more of the problem. Go through the diagnostic report, you will see that organic reactions is the mostly poor answered question. So what do they want to do as examiners? We want to enhance the understanding or the concept by ensuring that we continue on assessing, we continue on giving advices, we continue in ensuring that this particular concept is one that is now going to be closing or having more challenges. So the exams are set to test the skill, yes, but in actual fact to correct the problems or the challenges of the previous cohort. So electrolytic cell 10 marks, galvanic cell, ladies and gentlemen, at 17 marks. So this is just a distribution of marks per topic. This includes the multiple choices also for how best can we say. But if we look on this particular topic, then we stand a better chance of ensuring that our learners can do well. So colleagues, let me quickly highlight the ones that are more important. It's this one, this one, this one, and this one. All important, but if emphasis is done to understand that we want the learners to pass, it will be best, ladies and gentlemen, if we can focus on closing the gaps in this given specific topics. Why? Mark contribution, colleagues, key challenges identified in those ones. So it's important that we ensure that we assist our learners the best way we can. Now, colleagues, are we teaching with the understanding of the industrial applications? Yes, we have identified to say we are going to assist them with these highlighted topics for them to actually get marks. But when we do that, we use previous question papers. Okay, no problem. Does the previous question paper or does my teaching assist in terms of industrial application? And not only industrial application, but also the technology thereof. Why, ladies and gentlemen? Very easy. As per the slide says, the context of the applicable technology. So if we need electronic properties to address certain issues of technology, are we teaching to capacitate for the learners to actually understand the impact in terms of technology or the industrial application of this particular topics? So colleagues, as we revise, please, let's have industrial application of now what? All the highlighted topics. You will see I have included few trends for us to look into, to say, but this question, it is now addressing these issues of industrial application. And I gave you a reason. It is the foreword of now one of the CAPS document. Technical sciences for skills of engineering, full stop. Multiple choice, colleagues. 5 items, each 2 marks is equals to 10. Multiple choice questions test learners' understanding of concepts, principles, laws, and relationship between dependent, independent, and constant variables. This must be demonstrated through logical reasoning, not by engaging in lengthy calculations. Conceptual understanding. Demonstrate the level of now what? Of logic reasoning. That science talk we spoke about, the chemistry vocabulary and words per topic now comes in to say, are you able to give a logic reasoning? And during teaching and learning, carefully selected concrete examples must be worked out to demonstrate these concepts, laws, and principles. Now, what do we do, ladies and gentlemen? In our daily activities, is question papers, like I said. I don't see any multiple choice. When did these learners now practice on how to answer the multiple choice? When did these learners experience to say, but this is a technique of having the multiple choice? So as we revise logic reasoning, understanding of concepts, principles, and laws, and you cannot choose the correct answer if your lack of understanding is there, if you don't have a logic, a reasoning that you can assist or be assisted by a certain law or a certain relationship or a principle that governs the entire science that we are referring to. Learners must also be encouraged to refer to the formula sheet, because at times it gives summaries of laws, principles, as well as the relationship between the variables. Colleagues, I have included this one specifically and deliberately to say our learners are losing a lot of marks in paper 2 just because they are not using the formula sheet. The answering of multiple choice questions is a skill that needs to be developed. We need to have it day in and day out. Multiple choice questions should be used in assessment on a regular basis for all topics that are covered. That 10 marks out of the 75, it's important. For one not to be frustrated by 1.1, the skill of answering the multiple choice should be there. The skill of how to manipulate the strategies and answers given for me to actually be at least at 70% of the most correct answer. It's not something that I will learn over the exam or in the examination room. It's a skill that needs to be developed. So let's not just cut and paste the question, but we need to engineer the questions such that the skill of multiple choice can also be developed. Why, ladies and gentlemen? For a simple reason. Understanding of concepts and logical reasoning. And with logical reasoning, it's easy for one now to understand the assessment even further. Ladies and gentlemen, I have a nice question here of the multiple choice as a demonstration to say how best can we capacitate our learners. I am not interested in the correct answer. I am interested in, do we have a strategy of assisting them? Do we have methods or ways that we can add into these ones to actually be in a position of choosing the correct answer? Learners must be guided to eliminate the wrong answers through regular practice and assessment. Colleagues, I am at bullet number 2. Always two obviously incorrect answers will be given. And these two that are obviously incorrect, we call them the distractors. Will they be able to have a way of eliminating the distractors? And this should be obvious. For me, one will say B should immediately be completely incorrect, because there's nowhere or anywhere in technical sciences where they say we need to talk of elimination. I have not read the question. Already, I'm in a position of eliminating one. Now the question is, what is it that is needed here for one to understand? Is to apply the science concepts, laws, and principles. And how will they be able or be in a position of doing that? Is by them drawing this particular structure into a nice organic molecule. Then they can easily say, but I am starting now from what? From a unsaturated hydrocarbon to a saturated hydrocarbon. This is now the simple science that they need to know. And if that is the case, this should be an addition reaction. It's now applying science concepts, laws, and principle. Already once they have now identified to say unsaturated to saturated, that must be an addition reaction. It basically says substitution cannot be the most correct answer. A skill of eliminating two obviously incorrect answers, and they will be given. But now for me to be convincing and be in a position of applying the correct science concept, I need to know the knowledge, prior knowledge. I need to understand in actual fact now what, ladies and gentlemen, the conceptual understanding. The logic that we are referring to is now how to identify the reaction as addition, substitution, and what alternative name can be given to that. And it's clear, ladies and gentlemen, they did not add a halogen there. They added a hydrogen. So the fact that yes, it is addition at C, but now it says halogenation, and now that law or concept or the principle, it says, but here they should have now added a halogen. However, only here it's now addition of H2 gas. So the only correct answer, ladies and gentlemen, now becomes C. But already, as we are sitting here as a collective, as the teachers of the country and the best teachers in the country, because we are all performing at 99 point something percent with 60 average or 50 average, we could have easily went into the correct answer is D because of hydrogenation. But as a learner, I am not exposed to such understanding or the experience of basically going straight to the answer. That is the reason why eliminate the distractors and the two obvious ones will be there. And then apply the science concepts. And the science concepts you cannot apply if there are gaps within your understanding of the topics. So choose the correct answer. We have already done that. Colleagues, for organic, we will come here. That was just an example of the multiple choice. We will engage further as we move. And then this is just concepts check. What do we mean by concept checks? Concept checks is things that in this specific topic, what are the key things that one needs to be aware of? One, defining an organic molecule as molecules containing carbon. Immediately here, ladies and gentlemen, you introduce the chemistry of carbon. And when you introduce the chemistry of carbon, you explain now why carbon has a maximum of 4 bonds, or why hydrogen has a maximum of 1 bond. That chemistry now builds up into you explaining hydrocarbons are organic molecules that contain only carbon and hydrogen. So that chemistry of carbon is important as the underlying foundation before we can talk of any type of organic molecule or organic compounds after that. Because the question will be, why is this one having 4 and the double bond and what? Because of the lack of understanding of the chemistry of the carbon, and also the chemistry of oxygen as well as hydrogen. So it's important that maybe we should also include oxygen and hydrogen. As why? Because they form part also of everything, or the homologous series that we are looking into. Some of them do contain oxygen and some of them do contain hydrogen. So that chemistry, that learners being able to count 1, 2, 3, 4 when they work with the carbon, is a skill, colleagues, that we need to emphasize immediately. Once we say the chemistry of carbon, it means carbon behaves in this specific manner. So colleagues, it says here, they should be able to write the molecular and structural formula of the organic compounds up to 6 carbons of all the given homologous series, and no rings, colleagues, no ring structures, and that we have known so far. They should be able to differentiate between primary, secondary, and tertiary haloalkanes, as well as primary, secondary, and tertiary alcohols. That we know. The key issue here is, after identifying that this one is actually the correct homologous series, the challenge now becomes, do they know the general formula? Do they know how to give the IUPAC name? Can they draw or write the molecular formula? That now becomes the key challenge that all of us must be looking into. So colleagues, I took this for conceptual understanding, and like I said, conceptual understanding, the idea here is to say, without any questions, can you be able to engineer the given diagram and extract understanding from the diagram itself? We do not have questions on this one. It's just a diagram. And what is this diagram for? Is it for functional groups? Is it for the homologous series? It's important that now they are able to differentiate. A, B, C, D up to F its different types of functional groups? Will we be in a position of identifying the homologous series of each? And when will it be a homologous series? It will be a homologous series once we attach colleagues, once we attach hydrogens and other carbon atoms, such that now it becomes a complete structure. Then we can associate it with a specific homologous series. And immediately here, you explain to say the functional group, it's actually a bond or a group of atoms. They see it now. To say, but carbon cannot exist in an isolated manner. It will need to always have a maximum of 4 bonds. So with this question only, colleagues, I do not have questions. I don't know the questions. I want us to have a thinking of an engineer to say, can we engineer this question and have concept mapping? What do I mean by concept mapping? The learner should give you everything that has to do with A. They must tell you A, it's a double bond, and immediately thereafter to say, but if I see a double bond, it means the homologous series to which it belongs is going to be an alkene. Can they give you the general formula? Can they give you the suffix if they were to be asked an IUPAC name? Colleagues, it's just a simple question, but without questions, you can ask each and every one of them to say, give me anything that you know about D. Anything that you know about E. And these learners are clever. They will now say, I know 1, 2, 3, 4, 5. Thank you very much, Mendima. Please switch off the camera and the mic. Because now the bandwidth is becoming slower and slower. Thank you very
Maybe
much.
she's struggling to close it, but she will. Thank you.
Thank you very much. So, colleagues, the concept mapping and question engineering. Let's not take the question as it is and answer. They have seen it before. Even when you give this, the AI will ask them to say, what do you want to know? Because there are no questions to answer. So the engineering of the question allows us to enhance the conceptual understanding. Why? Because they will give you anything they know about a specific molecule that you are going to have chosen. So if you want to do something with C, you say to them, write anything that you know about C. There are no questions here. And then it becomes sequential understanding. To say before, now it becomes sequential understanding to say, before I can answer any table in the question paper, I need to interrogate the structures that are given. And interrogating the structures that are given will assist me in actual fact in answering the questions that are given. So our learners tend to do reverse classroom. They read the questions and they want the answer in the table. However, that's where now the problem comes. Why? Because the concept mapping of understanding the entire table and associating the table with the prior knowledge or question engineering becomes a challenge. Hence, it's important to say to them, identify the functional group and the homologous series. Expand and engineer to say which ones are saturated, which ones are unsaturated. Give me the general formula and give me the suffix thereof. Then they will say, but in Ntate Nambane, for A, I know that the suffix must be E. Colleagues, you have won already. Why? Because whatever comes here, it will be the understanding of the IUPAC names. If you say to them, give me the suffix of E in terms of the IUPAC name, then you are happy, colleagues, that you are going to have something like that there. Own or one, it's fine. Whatever comes now here will be the application of the IUPAC rules. But with a simple structure, a simple table, a simple diagram, you have managed to address issues of saying, identify the functional group, identify the homologous series, give the name of the functional group, and immediately thereof, you are able to ask anything related to this specific molecules that are given. And these are functional groups. How do they see them in the structures that are given? They will have seen it before, so they will know what to do. The issue of the general formula will say, yes, I know in terms of this general formula, this is definitely an alkane or single bonds. Give the suffix, then giving the suffix will say I will improve in terms of giving the correct IUPAC name. Because we'll find learners that have identified all the substituents, the parent chain, but they fail with the suffix because they don't know, is it double bond, triple bond, or which one is it in actual fact? Is it an aldehyde? Is it a ketone? Then they now start struggling. Why? Because of lack of conceptual understanding and the question engineering of them understanding the entire map or the table that is given is because of every time when we give them 2.1 define functional group, 2.2 identify a carboxylic acid, you will not be able to identify if you did not understand the given table. Same thing, colleagues, and I want to show you the difference between the two. These ones had alkene, alkane, haloalkane or alkyl halides, alcohol, ketone, and then another single bonds there. But when I now go to my second exercise, because this one says there are still outstanding functional groups or homologous series that we can interrogate as a collective. What do? I now choose an activity where now there is other different ones. Why? Because if I am working with this one only, the misconception already starts to say, maybe carboxylic acids are not so important. Maybe aldehydes are not so important. So the selection of choice of activities should enhance each and every bullet or address each and every bullet as well as enhancing the understanding. How do I do that? I'm also going to engineer for the other outstanding molecules. This is now activity number 2 of what? Increasing the knowledge and closing the gaps. So the engineering should also be part of this. Can it be the same principle? Let's see. The previous principle said saturation, general formula, and give the suffix thereof. Can I increase the understanding? Definitely, we can do so for these specific ones that are now given as activity number 2. So the layout of activities should also assist the learners in actual understanding of the concepts. So the question engineering, colleagues, even when you have made a copy of this and then you give it to them, the first thing that they are going to ask in Tate Shongwe is that, Mr. S, where are the questions? How do we answer? And then you say there are no questions. The question is, I want you to tell me and interrogate the information in front of you. Because if you give them questions, they will start by saying, no, number C, they want what, it's a carboxylic acid, and then it's a carboxylic group, and what. But if there are no questions, the fact that they see there are no questions, it entices their mind to say, what must I do? And that's the learning that we want. The learning will be interrogate the information before attempting to answer any question. And however, because this workshop is for the teachers, the things that I am referring to is things that we know in terms of sequential understanding. But now we are trying to close the gaps, colleagues. We are trying to ensure that each and every learner in the country is very now ready to compete with whatever paper 2026 and beyond in their life of chemistry. Colleagues, now we are happy. They know the functional groups. They know the functional, the homologous series. They know the general formula, the suffix and everything. Now they must give the IUPAC name. Colleagues, I have highlighted bullet number 4 in red. This is also an extract.
Make sure you wipe it. Please wipe the seat. Mom, can you please come here with the TV?
Can we get colleagues mute, please? Thank you.
Thank you very much. That is Tole. I highlighted bullet number 4. This is also an extract from the examination guideline. When naming haloalkanes, halogens do not get preference over alkyl groups. Numbering should start from the end nearest to the first substituent, either the alkyl group or the halogen. In haloalkanes, where e.g. a bromine and a chlorine have the same number when numbered from different ends of the chain, Br gets alphabetical preference. When an alkyl group is a substituent in a molecule, it should be treated as a substituent. All other homologous series, our learners are doing well. Butane 2-O, they know those things. They are trying their level best. But now put a haloalkane there. That's where now the challenge starts. How do we assist them? We read this rule. But after reading the rule, colleagues, we need to find a way of ensuring that the misconception at number 4 is outlined. How do we do that? Apply the IUPAC name rules. The rules are also there in the examination guideline. I did not want to include them because we are closing the gaps. And the key gap here is naming of the haloalkanes. And we want to entice and bring about excitement into the learner's understanding. So colleagues, I said there by bullet number 2, use ChemSketch as a teaching tool and outline the misconception, especially bullet number 4. Memtlala, your hand is up. The feeling of the house was we finish and then we'll take inputs later. So let me kindly continue, colleagues. Now, use ChemSketch as a teaching tool and outline misconceptions, especially bullet number 4. Let's see, colleagues. I have these two learners here, and this structure is given. And they say to the learners, write down the IUPAC name of the given organic molecule. It will be easy to answer by applying the rules, but should the rules not be applied correctly, then we are automatically going to have these two different answers. Now the question is, which one of the two is the most correct one? Because 2,4 dibromo 3-chloro 2-methyl pentane sounds nice to me, sounds correct. But now I have the learner in blue who also said 2,4 dibromo 3-chloro 4-methyl pentane. Now there's a debate in class to say, but why is mine wrong and why is mine correct? Simple English, application of the rules. But to entice the learner's excitement to know is to say, if you do not apply the rules of IUPAC, it means everything is going to be not so good. That is the reason why, colleagues, I felt that maybe it's important for us also to say, let's draw this particular structure together. And us using the ICT tools to actually enhance this understanding. Colleagues, is going to be 1, 2, 3, 4, 5 carbons. And then I'm just going to say this one will be easy to draw. Just going to go to tools and say add explicit hydrogens. Why explicit hydrogens? Because I just want to choose the atom that I want to replace there. So I want to replace at carbon number 2 this one with the Br, and then at carbon number 4 also I must have the Br. But there's also a Cl in our structure, and that Cl is sitting at this particular carbon. And now I want us to do this if it allows me to, but I must delete now one hydrogen. Why, ladies and gentlemen? Carbon can only have a maximum of 4 bonds. So already that background of chemistry of carbon assists to say even the platforms where you can use diagrams and sketches does not allow, because that science is incorrect. So already you have said to them you are eliminating the issue of having carbon with 5 bonds. So we must remove this, ladies and gentlemen, and also add the explicit hydrogen. So this is a nice molecule, and I want to say it is the same as the one that was given here. But now I am in class, I'm trying to entice them, assist them, to show them that the rules are applicable everywhere. And if you do not apply the rules, that is the reason why you get now the ones that are incorrect. Then from here, colleagues, it's a nice application. You can generate the name of the structure. And generating the name of the structure says to us 2,4 dibromo 3-chloro 2-methyl pentane. Ladies and gentlemen, is it correct? Let's go back and check. We have now 2,4 dibromo 3-chloro 2-methyl pentane, which suggests now, ladies and gentlemen, to say this one is actually the most correct one. But we need to give reasons to this learner to say, but why not? A simple rule, colleagues, a simple rule that if they do not have an app like us for enhancement of the teaching, it means they must just check to say the total. Okay, the total sum.
Sorry, Mr. Nambane.
Yes, sir.
On the chat, Mem Lala said they cannot hear on their side. I don't know the problem is on their side or I'm not sure. Maybe that's why was
Alright.
raising a hand. So I'm not sure. Can I just find that from her? Mem Lala?
Yeah, Bunjabu, I'm okay
Yes.
now. I've rejoined, then I'm okay. Thanks.
Oh, okay, thank you. I'm sorry, Mr. Nambane. I'm sorry for that. Thank you.
No problem, that is totally. Thank you, Memtala, all the way from Limpopo. Maybe the network there is a challenge, ma'am, but we are happy that you are fine. Now that is totally, as a science person, my logical reasoning is now lost. I must regroup my thoughts again.
I'm sorry. I'm sorry.
The total sum, yes, the total sum of the substituents, because everything now becomes a substituents, should be the lowest. I don't know if that will make sense. So the idea with this bullet number 4 of haloalkanes is whenever they add the total of the substituents, the one that gives the lowest is the one that will be the most correct one. Because why, colleagues? Because in the exam they do not have now the chem sketch for them to actually work with checking their answers and everything. So a chem sketch is just a tool, colleagues, just to enhance the understanding. And I'm going to quickly delete this one and draw something simple, but changing the organic molecule or the functional group. Let's try to have an alcohol with 4 an alcohol. Okay, let's try carboxylic acid. Then, colleagues, I'm going to need an oxygen, so I will include the oxygen there, include another oxygen there. But now it says even if I add the explicit hydrogens, this is not an alcohol, it's actually an aldehyde. But I want now what? I want a carboxylic acid. So I'm going to just add that, but we know now that carbon can only have a maximum of 4 bonds. So colleagues, I will delete this one, then I have my nice structure of the carboxylic acid. Now what I want to do here, generate the name is not a problem. It will give me butanoic acid. Immediately thereafter, what else can I do? Colleagues, I can write something like the molecular formula of the structure. Remember, it's one of the bullets that was there to say write down the molecular formula of the given structure. So it's a nice tool to actually enhance the learner's understanding, but they do not have in the exam. So we use this just to ensure that you are in a position of engineering the questions as you move. Anything that you think of from the structure, give me the IUPAC, give me the molecular formula, from the isomers if there are any, and then the concept of teaching starts to flow. Why? Because of us actually having the tools that assists our learners to understand the concepts given. So with haloalkanes, colleagues, that is the tip that I want to share with the entire country. That is the idea that says everything now becomes a substituent. So it does not matter if you count from left to right, but it matters as to say what is the final answer you are giving to the marker and the examiner. Did you apply the rules 100%? Did the teacher use ChemSketch to enhance understanding? If we did so, then it means application of the rules is also emphasized, ladies and gentlemen. Furthermore, a simple hint is to say the total sum of the substituents should be the lowest. So you give them the 2 to say, but why are you now saying 2,4 dibromo 3-chloro 2-methyl is actually the most correct one? If the rules are all applied correctly and everything now becomes a substituent, then you tell them that the total sum of the substituents should be the lowest. So the one that gives us the lowest between the two is the one that is the most correct. Because why? We need to use the word most, colleagues, for a simple reason. If we give them 2,4 dibromo 3-chloro 4-methyl pentane, they are going to draw the same structure. So it is not wrong. It is just that according to the rules, 2,4 dibromo 3-chloro 2-methyl pentane is the most correct one in terms of application of the rules. So colleagues, please, all others as per the diagnostic reports, they do not have much of challenges. The challenge is on my naming of the haloalkanes. Colleague, structural isomers, organic molecules with same molecular formula but different structural formula. Thank you. So why, colleagues, emphasize is brought to organic molecules or structural isomers? Because there's a simple link from isomers to, in actual fact, physical properties. So we should not make a mistake of us not fully engaging with structural isomers. In terms of their different types, chain isomer, same molecular formula but different types of chains. Then we explain in terms of what is happening there. We like this one of butane because it is the most common one. But they need now to understand to say the chain now becomes shorter. And the concept says if I started with 5 carbons and 6 hydrogens and what, I must have the same number of carbons, same number of hydrogens. The only thing that must change is the type of what? Of the chain. So the number of carbons remain the same. You will see when we move now into a physical and chemical properties is to say, but this concept of chain isomers or isomers in general, it's important. Why, ladies and gentlemen? Because there's a nice integration between this and physical properties. So don't be shocked when at some point there's something that has to do with physical properties. We see it in question number 2 where we are used to naming of structures. Why? The integration of the concepts, colleagues. That is the new trend. Positional isomers, same molecular formula but different positions of the side chain. Colleagues, the examples are there. We have emphasized it more and more, but what is now changing here, it is just the position of either the functional group or one of the substituents. So it's important for also us to emphasize positional isomers. Colleagues, functional isomers, we have same molecular formula but different functional groups. Now, emphasis, different functional groups. For an exam tip, we need to tell them to say an aldehyde will change to a ketone and a ketone will change to an aldehyde. It's important that they understand that. Why? They're different functional group, but same molecular formula. So if your aldehyde had 6 carbons, you must still have 6 carbons on the ketone that you are forming. But you will not be able to form a ketone if you fail to identify that this is an aldehyde. So that activity that we started with of identifying the functional group assists us in this particular part of functional isomers. And then you must further tell them to say if I'm working with an ester, it must change to a carboxylic acid. And if I start from the carboxylic acid, it must now change to the ester. But if you do not know now the functional group of an ester, you will automatically fail to give the name, fail to give the structure, or even general formula for that matter. So colleagues, emphasis on key bullets, especially those ones of identification of functional groups as well as the homologous series. Because from this, colleagues, you can see there's no way you can understand functional isomers just by thinking you know something. So hence that activity to enhance the understanding of functional groups as well as the homologous series and the general formulas there, because nice questions here will be how will the boiling point of the functional isomer of compare to that of. It's nice questions that can come here, but now you fail to understand or give a correct answer because there's nice vocabulary, the functional group of an isomer of. So that chemistry vocabulary we spoke about, it's important that we teach with the correct chemistry vocabulary. Why? For the learners to understand exactly what this question wants. We had such an issue here in our province where we were even called to say, this question is not clear. But we said you do not understand the chemistry vocabulary. This question is saying the isomer of. And the isomer of is not given in the table. So it was just dear Makar, and because they did not have a clear understanding of isomers. Colleagues, remedial actions, please. We have identified challenges and key concepts that our learners are failing with. So the valence of different elements is important. That is the chemistry, only forming 4 bonds, and hydrogen only 1, and should be emphasized, colleagues, when writing the IUPAC names. The following should be emphasized also. Use of hyphens and commas correctly. The prefixes di, tri, and so forth, very, very, very important. When compounds has only 2 carbons atoms, numbering must not be used to indicate the position of the functional group. It should be ethanol, not ethane 1-ol, if there's only 2 carbons. Substituents must be written in an alphabetical order in an IUPAC names regardless of their position in the longest chain. That is the example we did now, colleagues, with what? With that 2,4 dibromotrichloro. Very, very important. You now address issues of alphabetical order, regardless of now what their position in the parent chain or the longest chain. Colleagues, as a remedial action, emphasize the difference between molecular formula, structural formula, and condensed formula. Use condensed structural formula more often in exercises to assist learners interpret such formulae. emphasize the functional groups of carboxylic acids and aldehydes are not numbered when writing the IUPAC names. We've seen it in our marking centers. 1-butanal, butane 1-al. In a carboxylic acids and aldehydes, the functional group is always the first carbon and is not numbered. However, functional groups of alcohol, alkenes, alkyne, and ketones should be numbered because the functional group can be on different carbon atoms. And this now for alcohols, it will be now emphasis on what, ladies and gentlemen, primary, tertiary, and secondary, because there will be other carbons surrounding the carbon bonded to the functional group. So very, very important, colleagues. So these are the remedial actions that we need to go with when we treat the revision part of this particular chemistry. Colleagues, organic properties or physical properties rather, concepts check from the examination guideline. Discuss relationship in physical properties of alkenes, alkynes, alkyl halides, ketones, alcohols, carboxylic, and esters. Compare their physical properties of different homologous series for a given example from the above functional groups. Explain the relationship between their physical properties and the strength of intermolecular forces, type of functional groups, chain length, and branching. Now, colleagues, the question is here. What are these physical properties that we are referring to? Boiling point, melting point, vapor pressure. And everything in here now becomes a dependent variable. And you will be in a position of explaining why. Because chain length, number of branches, functional group are the factors that affect boiling point, melting point, and vapor pressure. Learners will not be able to answer before they can actually identify the factor. Identify the factor. Because the factor influences how we are going to answer. The factor influences how the dependent variable is going to be. Now, there are ways that some of us are not aware of. And I get this question a lot of times to say, when is it chain length and when is it branching? And what must we say in the exam or give an answer to if this is asked? Colleagues, one, for us to compare in terms of chain length, the organic molecules that we are comparing should belong to the same homologous series. You cannot compare chain length and you want to compare chain length with an alkene and aldehyde. First things first, they must belong to the same homologous series, which means they must have the same functional group. For the number of branches, they must also have the same homologous series. Now I am sitting in that exam and saying, yes, they have the same homologous series. I need now something extra for me to have a conclusive and a deductive conclusion to say this man or this examiner or this lady examiner is asking me about chain length. No doubt. then we need to add another different concept. And that concept is to say these two we combine. I checked the exam guideline, it does not say anything about the molecular mass. But I included the molecular mass to say some of the tables given, they will indicate the molecular mass, just to confuse our learners, or just to indicate that there's an increase or decrease in the number of carbons. Colleagues, once our learners are happy to say this that I am comparing A, B, C, D belongs to the same homologous series, they need to take it one step further. Am I comparing in terms of different number of carbons? A, one carbon, two carbons, three carbons. But do they belong to the same homologous series? 100%. So once they belong to the same homologous series and they have different number of carbons, ladies and gentlemen, the questions that follow should be questions that are asking us, how does increase in chain length affect boiling point, melting point, and vapor pressure? Furthermore, we say they belong to the same homologous series. Now I want to be sure that these examiners are asking me of the number of branches. What must happen, colleagues? We tick, they belong to the same homologous series, correct. Are they isomers of each other? Now we did not teach the isomers correctly in the previous topic. So the learner is struggling to say, yes, what is the other one? The other one must be isomers. What does isomers mean? Same number of carbons, same number of hydrogen, same everything in terms of the molecular formula. But the only thing that will change is now the structure. So I added here, I should actually add same number of carbons, same number of hydrogens, same number of oxygens, if that is allowed. But the key factor here is the number of carbons must be the same. So you cannot compare the number of branches and say, no, this one has one and then this one has two. Automatically that is going to be incorrect, because once we have 1 and 2, it means we are comparing in terms of different number of carbons. So if it is butane, let's add it here. Butane, 4 carbons, and then 2 methyl propane, 4 carbons. Are they isomers of each other? Correct. Then you cannot say butane has a longer chain than 2 methyl propane or strong. You can do so. But in actual fact, we want an answer that says butane is a straight chain and 2 methyl propane is now a branched chain, or 2 methyl propane has 1 branch more than butane. Then you start explaining, because you are happy to say in actual fact the number of branches is the one that is influencing in terms of our dependent variable that we are referring to. So colleagues, it's important. They answer just because they want to answer, because there's no conceptual understanding, there's no logical reasoning. So the logical reasoning says, identify, do they belong to the same homologous series? 100%. Are they isomers of each other? Yes. Then my first bullet in answering must be to compare in terms of the number of branches. Do they belong to the same homologous series? Correct. Do they have the different number of carbons? Correct. Then it is chain length. Then bullet number 1, compound A has a longer chain than, and then you explain in terms of the strength of the intermolecular forces. Colleagues, we have seen it and you know it. They are quick to say, London forces, dipole, hydrogen bonds. They are quick to say that. But they lose a lot of marks when now they need to explain to say they have the same type of intermolecular forces. So, but why does the boiling point differ, the melting point differ, and the vapor pressure? They fail to comprehend and understand. They will talk about the number of branches, they will talk about the functional group, and that is not what is being asked. And the trend now is this thing of negative marking to say which compound A or B or C, write only C, give a reason. Then once you chose the one that is incorrect, the follow-up statement says you cannot give a reason to an incorrect answer. Finish and clear. So colleagues, it is important. With functional group is very simple. They must belong to different homologous series. And they must specify to say this is an alkene, it has London dispersion forces. This is an ester, it has dipole-dipole. This is a carboxylic acid, it has hydrogen bonds. Thereafter, now they must compare in terms of their relative strength. That they are able to do, colleagues. My worry and concern was chain length and the number of branching. And everything here then becomes an independent variable. So we are nice and clear for us to actually explain these concepts. Colleagues, now, somebody said graphs, technical sciences, you are making the paper difficult for the learners. Colleagues, it's the trend, it's the understanding. The definition of boiling point. Hence, one of the slides said, please try to explain the relationship between dependent, independent, and controlled, as well as any principle or definition or law that is within our context. This, I don't have the questions because we agreed as a collective to say we continue with now what? With engineering of concepts and mapping of concepts. This one, Claire says to me, what is this? But now I should be quick to say a definition of boiling point says the temperature at which the vapor pressure is equals to the atmospheric pressure. Did they ask something out of the context? No, they did not, colleagues, because the concept of the definition of the boiling point is exactly what this graph is suggesting. So when we have an opportunity of explaining the relationships in terms of a graphical way, we should be able to do so. And if we are able to do so, colleagues, then it will mean it's important for them to now identify the factor that is being assessed. And the graph is for A, butane 1-ol. Butane 2-ol, C, propanoic acid. So all of them, they belong now to what? A different homologous series. So whatever factor that is being assessed there must be the factor of the functional group, the influence of the functional group into now what? The melting point and the boiling point, colleagues. Hence, it is important to interpret the graph. Is it the concept that is not there in technical sciences? It is there, ladies and gentlemen. So the integration of concepts and the relationship is what we need to emphasize. This is just a pure definition of boiling point. Furthermore, another one in terms of definitions and graphical representation, colleagues, it says the relationship between boiling point and the number of carbons in a straight chain molecules of aldehydes, alkenes, and primary alcohols. Curve A, B, and C are obtained. No problem. It is just data interpretation. Is it out of scope? Not out of scope. Why, ladies and gentlemen? Because we agreed to say chain length, or in terms of the number of carbons, number of branches, and then the functional group are the factors that influence boiling point, melting point, and vapor pressure. So colleagues, it is within the scope. Let's expose our learners into this. Very, very important and critical. Identify the factor being assessed, interpret the graph. Once we have done this, colleagues, please, now I think it's safe to say, include now the concept of vapor pressure. Very, very important for us to look into that. So please, colleagues, let's do that. And look at this. If I were a learner, already I'm getting scared. Why? Because I'm used to the graph, maybe. I'm used to the table, the data from the table. But now, what is this? What is this? Okay, fine. It's not a problem. I'm in an exam. I need to start conceptualizing and understanding the question. It says now, the table below shows some organic molecules that are commonly used in everyday life. Daily life explanation or integration. Furthermore, industry related, technology related. That is now the new trend, colleagues. The general formula for these compounds is CnH2n plus 2n. Where does this now come from? The integration we spoke about. Question number 2, naming and naming of structures or nomenclature in simple terms now comes here to say, but if you don't know what are these, and in terms of them being different in terms of the boiling points there, you will not be able to take a conclusive decision. So the question, furthermore, it's just an engineering type of question. It's a question that we need to engineer because these learners must understand to say 60 to 90, okay, it means it has less number of carbons. 150 to 280, okay, it must be in the middle in terms of the number of carbons. Boiling point of 370 degrees must be the one with the higher number of carbons. So what are you actually checking here? A lot of factors can be assessed, but the fact that they belong to the same homologous series, it definitely says it's important for one to say it's chain length, yes, and because of the reasons that will be alluded there. So the trend, colleagues, industry applications, and identify the factor, relate the identified factor to the theory. So colleagues, new trend, like I said, application in the industry. Very, very, very important. So imagine if this was an exam and we did not prepare our learners, colleagues, we will all lose our jobs. Organic reactions, concept checks, you have this, colleagues. I will just pass for the sake of time. And colleagues, these are the reactions that we need to be looking into. Colleagues, there is an analogy that says triple S and USA. Single and seriously searching and I went to the United States of America. This means if I am moving from saturated to saturated, colleagues, this reaction must be substitution. We are trying to help them, but at times they just get everything dear magar. If I am moving from unsaturated to saturated, that reaction, colleagues, must be an addition reaction. Then it will be an issue of which type of addition it is and the conditions thereof. But once they are able to identify in terms of the analogy of single and seriously searching and went to the United States of America, it will assist in terms of being 100% confident to say this is substitution, this is addition. We will only now struggle to say, is it addition of a type of addition which is hydrogenation, hydrohalogenation, halogenation, and hydration. And colleagues, I want you to engage with this slide to say how best can we assist them, because all those questions, they usually just ask type of addition, or is it addition, the catalyst needed, the conditions needed, and furthermore they ask something also like the IUPAC also there, draw the structural formula, which is the previous knowledge or prior knowledge because of the concepts that we started with. But I want now us to have a system, colleagues, that says, now man, these learners can actually use the triple S and the USA to have an idea to say this reaction is addition. I'm not going to take any other thing. How do you know it's addition? No, I know because it is starting from unsaturated to saturated. But now what type of addition? If you have any other nice analogy, colleagues, for us to discuss and share this today, please do so. Furthermore, this will be easy. I want to apply the analogy. You unsaturated, saturated, and then automatically it will move to saturated, and which will mean I must have single bonds there. And clear, colleagues, you can see it is starting from unsaturated to compound Z. This one also, one can easily say this must be an addition. This one also must be an addition. But now, Y to Z is starting from saturated to saturated. Then definitely this must be a substitution. So I am happy with that. The only challenge now that I have is this learner of mine is applying the analogy correctly. But now they are not asking whether it is addition. They are asking the type of addition. How will the learner know that it is hydrohalogenation and it will be hydration? Colleagues, that is what puzzles me. I do not have an entire key strategy of assisting the learners. Hence, when I was giving this, I said it is a collective input. Share how you have been doing things such that you can get a collaborative effort from other colleagues. We modify, we enhance, and then we capacitate the learners before the trial examination. So hence, colleagues, if you have any other thing nice about how can they know that it is H2O, then it is hydration and what, please, all those nice analogies that you have, please kindly share. And furthermore, colleagues, 2-methylbutane appears as a clear colorless liquid with a petroleum-like odor. Again, industry, colleagues, Can it be a coincidence? No. The examiners are just acclimatizing themselves with the foreword of the CAPS document. They are assigning themselves with now what needs to be assessed for enhancement of the subject. Colleagues, identify saturated and unsaturated. Very happy with that. Application in the industry, very, 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 very clear. And for galvanic cell, colleagues, I don't know how you do it, colleagues. we all have ways of doing it. And in all of us, there is a science learner, you as the teacher, when you were doing the science. There's an engineer in you or a doctor in you and a teacher in you also. And furthermore, there is a logical approach in terms of the personality that we have as individuals. Colleagues, every time when I teach a galvanic cell, I don't teach the cell first. I teach the concepts. I deliberately did not type these things out as it's part of my notes as I am teaching. So I wanted to show you that when I start with the galvanic cell as my practice, might be wrong, I explain the concepts of oxidation and reduction in detail, relating it to the concepts of grade 11 work of oxidation and reduction, giving the definition of loss of electrons, gain of electrons, reducing agent, oxidizing agent. I introduce the words of oxidized and reduced before talking about the cell, because I am one person who understands that the cell is built up from the electrochemistry. The cell is not built up as a standalone. The cell operates under the mutual understanding of the electrochemistry. And once I have done this, whether it is galvanic or electrolytic, oxidation is oxidation. Reduction is reduction. Reducing agent is a substance or a species that is oxidized or that is losing the electrons. So from this, colleagues, it's easy for the learners to comprehend and understand that. From there, I don't tell them about positive and negative. I just say oxidation takes place at anode and reduction takes place at cathode. Now the question will be, why will the cathode now change in the galvanic cell or in the electrolytic cell? It does not change because the concept is the same. We will now explain in detail as to what happens and what analogies do we have such that learners can actually remember this. So colleagues, I will not bore you with this, but I included this last bullet is an increase in oxidation number, is a decrease in oxidation number. I recently added it. These notes will normally end at anode and cathode. But then I realized to say, hey, what if now they are given the cell notation and then they must say some things there? What if they are given the net cell and it is rearranged in a certain way? Will they be able to identify the process of oxidation and the process of reduction? So I added this for me to try and explain in terms of the oxidation numbers. Just to say, I want to close the gap. The trend is they have not asked such a question where they give the learners a net cell So when the net cell is given and it is not written in a standard way of us knowing it, will they be able to answer? Because it does not say the chemistry is only for zinc copper cell. It says any other cells can be used. So if it is something that they are not familiar with, will they be in a position of answering? That is the reason why, ladies and gentlemen, key concept, explain the science behind this. The cell is built on one understanding these processes. Colleagues, explain key concepts before introducing the cell and use the formula sheet. You know the definitions and everything. What do I mean by use the formula sheet? Colleagues, it is here. There are a lot of analogies. Oil rig, oil rack, what, all nice ones. But now I'm in an exam, colleagues. The only thing that I can trust is the formula sheet. Colleagues, there's a negative here and there's a plus here. The plus in mathematics means increase or gain. The minus in the mathematics means less or loss. So we have explained to them to say electrochemistry is actually the transfer of now what? Of energy. But that is being done in terms of what? In terms of electron transfer. So reduction, because of the positive in front of the equation, is actually what? A gain in electrons. I am using formula sheet. Why? Because it is there. Now imagine I come with triple S and USA. Now I must come with another difficult analogy of a triple oil for me to remember. It is working, colleagues. I am not saying they are not working, but I am saying the formula sheet is there. So let's minimize them having a lot of words to memorize and apply. The formula sheet is there to assist. Oxidation, because of the negative, is very simple, loss of electrons. But the substance that is losing electrons, it is called a reducing agent. The substance that is gaining electrons, it is called an oxidizing agent. So these are species or substances, and this side also. Furthermore, we can say, where is it taking place? The electrode where oxidation takes place is anode, and the electrode where reduction takes place is cathode. So this they have. It is in the formula sheet. The only thing they need to do is for them to understand the concept. Now you can talk of the polarity. To say, but now look, we said an electrode is a metal. That metal must be positive. This metal of the anode must be negative. Why, ladies and gentlemen? Because of the formula sheet actually has all the answers they need. I did not refer to any cell at this point in time. I want them to understand the concept of reduction, oxidizing, and reducing agent. And then I'm only going to introduce one simple word for me to correct the issue of when is it a galvanic cell in terms of the polarity of the electrodes, and what is the polarity in terms of the galvanic electrolytic cell. But the concept is the same. They must know that at cathode, whether it is electrolytic or galvanic, at cathode reduction takes place, and I'm going to find my oxidizing agent there. whether it is a galvanic cell or electrolytic cell. At anode, I'm going to find my oxidation there as a process and my reducing agent there. This does not change. The only thing that I will now worry about is to say, in this cell, the only difference is this one. So this concept is said, please explain the key concepts before introducing the cell and use the formula sheet. We have explained that, colleagues. Colleagues, these are the notes that I did. The presentation will be shared. Table 4B, ladies and gentlemen. Table 4B. And please emphasize the use of one arrow once the learner has identified to say, if I do my C, they call it A and C, something like that. Then I will get my anode and then I will get my cathode there. That is what they say in all the seminars that we attend. No problem at all. We want our learners for some reason to be able to identify oxidation and reduction. Can they explain in terms of reducing abilities? It's important to do so. Is it out of scope? No. It is just to explain that this one is a stronger reducing agent than gain of electrons in increasing of oxidizing ability. What does it mean when I'm saying I'm a strong oxidizing agent? It means I have the ability to force other substances to lose their electrons. So it's the science talk, the chemistry vocabulary that we need to enhance, colleagues. The N, I don't know what is for. The N, it says it's for the neutral, colleagues, which is there, that one of the hydrogen standard cell. That is what it means there. But it is important to say, if it is above that one, it stands a better chance of becoming a stronger reducing agent. So oxidation can take place easily. That is what it means. So it's important not just to say the one at the top is oxidation, the one at the bottom is reduction, because they both of them, they can actually be above the standard hydrogen potential. So it is important for each and every one of us to actually do what? Explain the table as it is given, ladies and gentlemen. Colleagues, use the formula sheet. Now I come to the galvanic cell. It's fine. I will not bore you with this. It's things that we know. Explain the key concepts before introducing the cell, and then use simulations to enhance understanding. Colleagues, these are the concepts that I'm referring to. Galvanic cell, keyword, it's a cell, and then energy conversion, and so forth and so forth. Fine, colleagues. Now I have the cell here. I don't know. Dark in color blue, a ray of sunshine in the shade. I promise that I'll never leave you. I'll save you from. Now I have this cell, colleagues. So when I was recording this video, you could hear, colleagues, there's a nice music such that at least it does not bore us in terms of the flow of electrons. Now here, colleagues, key things: you explain the oxidation, you explain the reduction, you have your oxidation and net cell, and then all of them, colleagues, should come there. Now here you can now start talking about the polarity of the cell. And what is nice about the simulation, it is that it actually shows the flow of electrons on the external circuit, flow of electrons on the external circuit, and it actually shows now the movement of the anions and cations within the salt bridge. So it's very, very important, because there's one question that they asked somewhere to say, what is the suitable ionic compound that can be used in the salt bridge. So colleagues, it's important that our learners know this. And what is the movement of anions? Are they moving towards the cathode and the anode and what? And it's easy, colleagues. Once they have identified oxidation and reduction, they can say a lot of things here to say this is now the cathode. Furthermore, this is now the oxidizing agent. So they will know exactly where to find all this important information. So colleagues, the link is there for you to use this nice simulation. It will assist the learners in terms of understanding. I was actually tempted to say the rate of oxidation is equals to the rate of reduction, but I then quickly remember to say, hey, don't say it. Why say it? Because the CAPS document does not refer to it, and the exam guideline does not refer to it. But as you play the simulation, colleagues, you will see the number of electrons that are exiting the zinc electrode are actually the same number of electrons that are being gained at the copper electrode. So let's use such tools, colleagues, to just enhance the understanding. But I want to go back here, because what I want to refer to is this part, colleagues, is this part. Determine the electrode potential of a galvanic cell, e.g. copper zinc cell or any other galvanic cell. So let's not limit our learners to copper zinc. It can be any other galvanic cell. So it is important, colleagues, it is important that we do that. Then I just included standard conditions and then the factors that affect the cell potential. This question was very nice in one of the questions to say the theory says it must be 1,10 volts, but the learners, after conducting the experiment, they found that no, it is not the same as the one in the theoretical calculation. What are the factors that contributed to that? So it's important to say concentration is one of them. Why? Because the cell must work on a standard conditions of a concentration of 1 mole per decimeter cubed, and the temperature should be maintained at 25 degrees Celsius or 298 kelvins. So colleagues, I want to, hence I said this part because we are recently busy with it. So I have the notes and everything handwritten when I also do my direct learner support here and there, just to show you that we are all on the ground. We are all trying to assist each other for us to actually get the desired results. So colleagues, with the electrolytic cell, remember they know the concepts of electrochemistry and how to use the formula. So this is nice. You just emphasize that and describe movement of ions, state the directions of electron flow, and then write equations of half reactions and anode and cathode overall, and then describe the decomposition of copper chloride and then electroplating. No problem. The first thing is to explain the difference or key concepts before introducing the cell. We have done that. But now we must say to them, how do you differentiate between an electrolytic cell and a galvanic cell? Now, colleagues, it is just like this. How will they know that which one is anode, which one is cathode? How will they know? Colleagues, we are quick to introduce positive and negative. Let's start by just saying they are connected to the battery, such that the energy conversion can be possible from electrical energy that is converted to chemical energy. Then we agree to say this must have or must be a DC source. And why must it be a DC source, ladies and gentlemen? The answer is very simple. To keep the polarity of the electrodes, constant. Nice and simple. Because once you put positive and negative, remember now you have said to them the electrode where oxidation takes place is negative. They will come with that here. That is the reason why we introduced a nice analogy of the word panic. I have given you now 3 words: triple S and panic. Those will be easy to understand. And panic simply says positive electrode, that is where anode is. Negative electrode is cathode. A negative electrode. So the word panic just says when I work with a galvanic cell, things changes now. Because I said when I use the formula sheet, cathode is positive, anode is negative. That they can use from the formula sheet when they work with the galvanic cell. But now the issue comes here to say, hey, this is an electrolytic cell. They don't tell me which is positive, which is negative. They just tell me it is a battery. So, but according to the word panic, positive is where anode, or positive is the anode electrode. Then I can go back. What happens at anode? Oxidation. What type of species will I get there? Ladies and gentlemen, it is a reducing agent. It is as simple as that. I don't know what happened here. Okay, is it back in that Tole?
Yes, sir. Yes, sir. Yes.
Thank you very much, sir. So now, already colleagues, these concepts were explained previously. These ones, they stay the same. The only thing that changed now is the polarity of the electrode. And then at cathode, colleagues, we said it also. What did we say? Reduction. And then also we are going to get our oxidizing agent. So colleagues, this is a lot of theory that they need to understand. Because now, what if I do not have such information here? So I'm going to add a lot of things. I'm going to say at anode, this is what is going to happen. And at cathode, this is what is going to happen. At anode, ladies and gentlemen, one attracts anions, the ones that are negative. And then at cathode, colleagues, attracts positive ions, and these ones we call them cation ions. So it's simple to say, if I am going to work now with Cu2 plus and Cl minus, and they must tell me that to say the ones that are positive are attracted there, then this must be my cathode. The ones that are negative are attracted there, then this must be my anode. And my anode, ladies and gentlemen, quick mistake also, you can see from Tate Nambane, it says positive electrode is the one that is anode. Then I can say this is positive, and then now this is negative. So the examiner must say something about cathode oxidation if they want to ask about polarity. If they give me the polarity, then I must understand that I'm going to use the polarity for identify anode and cathode and relate that to oxidation and reducing agent as well as the oxidizing agent. And they will say something maybe on the cathode also about increase in mass, or something about the appearance, ladies and gentlemen. Appearance, something that says in actual fact this one gained or lost. Then we can associate that with now what? With our analogy that we created of the word panic. So for galvanic cell, you use the formula sheet as it is. But now for an electrolytic cell, ladies and gentlemen, you use the word panic. But if we had chance and time, obviously you try and explain where this words comes from. But for now, it's important to say at anode, we know, ladies and gentlemen, oxidation takes place. What is the polarity of the electrode? It is positive. Simple. Can I identify the reducing agent? Simple, I can do that. Oxidizing agent, I can be in a position of doing that. Ladies and gentlemen, very easy and very simple. It's the summary of what we need to be looking into. And yes, colleagues, explain the concepts before doing that. And this is now electroplating. Colleagues, this is one of the pets that we are doing. It's very, very important, this pet. Please explain why we do electroplating. It is to improve the appearance, increase in value, and protect from rust. Can panic work here? Let's see. Panic is going to work. Positive anode. There's a lot of music, colleagues. So panic says anode this side, and then it says this one because it's connected to the negative, then we are going to have our cathode this side. Then everything, colleagues, remains the same in terms of the chemistry of electrochemical cells. And then, colleagues, you will see very, very simple to say there's now a flow of electrons as well as the ions there. So very, very important to note. And colleagues, that is the end of the concepts that I wanted to share with you. I could have easily went into deeper details. I tried my level best to give hints tricks and tips and outline common errors and how best can we enhance the teaching and learning. I even included smallanyana music for you to play such that the lesson does not get boring and just transfer of electrons. So colleagues, the journey continues, the challenges will forever be there, but this truck, this buggy, this van is going to that specified destination. So no matter how difficult it is in your corner, in your province, in your district, in your school, colleagues, let's continue on soldiering on. Let's never give up. Why, colleagues? It's very simple. When the plan is not working, change the plan but never change the goal. Our target is 100% for all the provinces, so the goal will not change. So if from whatever we did today and you feel that, hey, I was not aware of this one, there's no problem, colleagues. We just change the plan and continue working extremely hard. Ladies and gentlemen, with that being said, from me to you, ke a leboha, thank you, dinoluvua, ngiyathokoza, ke a leboga kudu. And that is Tole, Danki Paya, and colleagues, thank you very much for listening to this particular voice.
Thank you, Mtati. Realebo. Thank you so much. Oh, colleagues, let us give a round of applause. I don't know what to say. However, what a comprehensive, a very comprehensive and a detailed